So, today I will discuss some problem regarding to the mole concept. So, everyone open page number 41, 42 from your science textbook. Page number 42, problem number example 3.4. Okay. Now, read the problem. Calculate the mass of the following. Calculate the mass of the following. That is 0.5 mole of nitrogen gas. Now, 0.5 mole of N2 gas. Okay. Now, N2. What is the molecular mass of nitrogen? Here, respond. What is the molecular mass of nitrogen? What is the molecular mass of nitrogen, or 1 mole nitrogen equal to how many grams? Respond quickly. No, it is wrong. It is wrong. Not 14. Yes, 28. Yes, 28. So, 28 is the molecular mass. So, 1 mole N2 equal to the molecular mass of N2, that is 28 gram. Clear? Clear? Now, 0.5 mole of N2 equal to 28 into 0.5, that is equal to 14 gram. Easy. Clear? Clear up to this? Okay. Now, we will further proceed on that. Now, calculate the number of molecules. Calculate the number of molecules present in 14 gram of nitrogen gas. Calculate the number of molecules present in 14 gram of nitrogen gas. Okay. So, how we have to solve it? How we have to solve it? So, 14 gram of nitrogen, that is equal to how many moles? No, it is wrong. 14 gram of nitrogen equal to how many moles? So, you have to solve it in that manner. Okay, I am rubbing the previous problem. So, number of moles of nitrogen, that is equal to given mass by molecular mass. Given mass by molecular mass. Given mass is 14, molecular mass is 28, that is equal to 0.5 mole. Okay. Now, 1 mole contains how many particles? 6.023 into 10 to the power 23 number of particles or molecules, etc. So, here specifically it is molecule. So, 1 mole. So, how many mole? That is 0.5 mole contains 6.023 into 10 to the power 23 into 0.5 number of molecules. It is equal to 3.011 into 10 to the power 23 number of molecules. So, 14 gram of nitrogen contains 3.00011 into 10 to the power 23 number of molecules. Clear? Clear this? Okay. Now again I will continue this. Now you have to calculate the number of atoms present in 14 gram N2 gas. Calculate the number of atoms present in 14 gram of N2 gas. Can you solve it? 3 steps. First of all, calculate the number of moles, then the mole number of molecules, and then there is the new option. Yes, so solve it and tell me the number. Those who can solve it, try it. In the same way you will proceed. One Na atom, 1 mole, 14 gram, yes, correct, Riddhita. Okay, so you can proceed in the previous way, or there is another one option, that is 14 gram of nitrogen gas, that is equal to half mole. So I will proceed in that way, that is number of moles equal to given mass by molecular mass, that is 28, that is 0.5 mole, just like the previous one. Then number of molecules already done, equal to 3.011 into 10 to the power 23. Now as it is a diatomic gas, so the number of atom in one molecule is equal to 2, as it is a diatomic gas. So number of atoms present in 14 gram of N2 gas is equal to this value into 2. Is equal to, so 3.011 into 10 to the power 23 into 2 number of atoms, that is equal to 6.022 into 10 to the power 23 number of atoms. Na means sodium, Avogadro's number. N0 is this. Okay. So move to the next problem. 0.5 mole of N atom, 0.5 mole of sodium atom. So here the molecular mass is not required, here atomic mass is required. So the atomic mass of nitrogen is equal to 14. So 0.5 mole is equal to 14 into 0.5, that is 7 gram. Clear? 0.5 mole of sodium nitrogen atom, atomic mass of nitrogen is 14. So 0.5 mole equal to 14 into 0.5, that is 7 gram. Yes, not 2 into Avogadro's number, it is only 1 into the Avogadro's number, that is the Avogadro's number. Clear? Next, come to problem 3, that is 3.43. 3.011 into 10 to the power 23 number of n atoms. into 10 to the power 23. 10 to the power 23 number of n atom. You have to calculate the mass. Now we know that 6.023 into 10 to the power 23 number of n atoms mass equal to 14 gram, because this is the 1 mole. So, 1 mole nitrogen atom equal to 14 gram. Now, it is the half of that. So, 3.011 into 10 to the power 23 number of n atom, it is equal to 14 into 3.011 into 10 to the power 23 divided by 6.023 into 10 to the power 23. Now, simplifying it, you will get the 7 gram. Clear? So, the weight, that the mass of 3.00011 into 10 to the power 23 number of nitrogen atom is equal to 7 gram. Clear? And the fourth one is there, 6.022 into 10 to the power 23 number of N2 molecule. Now, 6.023 it is the Avogadro's number. So, these number of particles weight is equal to 1 mole, and 1 mole, that is its molar mass. So, the molar mass of nitrogen is equal to 28. So, the mass of Avogadro's number of molecules is equal to 28 gram in that case of nitrogen. This is problem number 4. Now, come to example 3.5. Any problem in problem number 3.4? Because you have to make a clear concept on that mole, because to solve the problem. Okay. So, next is that calculate the number of particles in each of the following. So, what we have to know, from weight to, from mass to number of particle and number of particle to mass. These two conversions you have to made in that class. So, the next is that 3.51, that (46 gram) of sodium atoms, 46 gram of sodium atom. Now, what is the atomic mass of sodium? So, atomic mass of sodium is equal to 23. Okay. Now, 46 gram. So, the number of particles. So, number of moles equal to 46 divided by 23, that is 2 moles. So, 1 moles is equal to 6.023 into 10 to the power 23. So, 2 moles, that is equal to 2 into Na or N0. 2 into N0 or 2 into 6.023 into 10 to the power 23, that is 12 into 046 into 10 to the power 23 number of particles. First one. Yes, 2 into Avogadro's number. You can also represent in that manner. Next one, 8 gram of oxygen molecule. Okay, so 8 gram of O2 molecule. Now, here the molar mass, 1 mole of oxygen is equal to how many gram? 1 mole of oxygen equal to how many gram? 1 mole of oxygen equal to how many gram? 32, yes. So 1 mole of oxygen equal to 32 gram. Now the given weight is equal to 8 gram. So number of moles is equal to given mass by molecular mass. It is equal to 8 by 32, that is 1 by 4 mole or 0.25 mole. Now it would be easier. So 1 mole contain Avogadro's number? Yes, it is Na by 4. So the number of oxygen molecules present is equal to Na by 4. Another one is there, that 0.1 mole of carbon atom, 0.1 mole of carbon atom. So it would be equal to, yes, 12 gram equal to 1 mole for carbon. .1 mole of carbon atom. So carbon's atomic mass equal to 12. So 0.1 mole, that is 1 mole having the particle number 6.023 into 10 to the power 23 number of carbon atom. 1 mole having this number of carbon atom. So 0.1 mole, that is 6.022 into 10 to the power 23 into 0.1 number of carbon atom. So here it is 6.022 into 10 to the power 22 number of carbon atom. How? Because 0.1 is equal to 1 into 10 to the power minus 1. Okay, so when we will multiply such kind of data, then it would be 10 to the power 23 into 10 to the power minus 1, that is 10 to the power, you know about it, that is 10 to the power 22. So here it is 6.022 into 10 to the power 22 number of carbon atom. Clear? Okay, these are the in-text problem was there. Now tell me about what is the formula unit mass of zinc oxide. Formula unit mass of zinc oxide. It was also an in-text question. This question may be converted to multiple choice type. What would be the formula unit mass of zinc oxide? Tell me quickly about this. What is the formula unit mass of zinc oxide? Okay, for your help, zinc equal to 65 U and oxygen equal to 16 U. Now calculate it. 81. So 65 plus 16, that is 1, yes, 81 U. So next calculate for K2CO3, yes, correct. Next calculate it for K2CO3. K2CO3 units is required. Potassium is 39. potassium is 39, carbon 12, oxygen 16. But sometimes the units may be missing, so you have to remember this. You have to remember these units because these are very important and very basic one. Now calculate it. (138). Okay, so 39 into 2, that is 78, plus 12 plus 16 into 3, that is 48. 78, 12 plus, that is 60, 8, yes, 138, yes, correct. Okay, now calculate it for such kind of formula. You do it yourself. CH3OH. Calculate the molecular mass of CH3OH. You can do it. Already we discussed about the atomic mass of carbon, hydrogen, oxygen. Calculate the molecular mass of the formula CH3OH. It is the formula of methanol. Methanol, it is an alcohol. Now you have to calculate the molar mass of methanol. So carbon 12 plus number of hydrogen atom is 4, that is 16. So 16 plus 16, that is 32. Yes, correct. Riddhita, Pratyay. Yes. Okay. And you can do it for C2H6. Can you do it for C2H6? Right. C2H6, 30U. Okay, so carbon is 12, hydrogen is 1. So 12 into 2 plus 6, that is 30U. Clear? So there, in that way we can calculate the molar mass. So 1 mole of methanol is equal to 32 gram. 1 mole of this is ethylene is equal to 30 gram. Okay. Now come to the exercise. Come to the exercise 0. Problem number 1. 1 and 2. Problem number 1 and 2 you will solve at your home. Try it at your home. Problem number 1 and 2. Here 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and dash gram of oxygen. Calculate the percentage composition of the compound by weight. So such type of problem is there in your exercise, in text exercise. Then when 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burnt with 50 gram of oxygen? Okay. So these two problems you will try to solve it at your home. Okay. So next day I will discuss next from that. Clear?